Hello. So today we're going to go quickly over transformations. Transformations. And in this course we're going to be primarily dealing with parabolas. So let's start with our base equation of y equals x squared. Okay. As we know, this graph will look something like, it's not too neat, but it'll look something like this. Right? And we can just confirm that going to Desmos, and we can write y equals x squared. So this will be our base function, and as we know, when we go to 1, 1 squared is going to be 1. So you see the point 1, 1. 2 squared is going to give us 4. We're going to see 2 to 4, so on and so forth with the negatives, right? So this is the base of all our functions. Now let's start looking at transformations. We're going to label it in this format. And we can call this K. Okay? These letters don't have too much meaning or value, just they each stand for something very important. So when you see this first number outside your bracket, this is dealing with the vertical stretch or compression. Alright, and let's see what that looks like. So let's say this number is 2. So we're going to see the graph that says y equals x squared, and then we're going to put a 2 out here. Right, so y equals 2x squared. Well, what does that mean? So that means when our point is 1, we're going to square 1, which will still give us 1. But now we have to multiply it by 2, so the point's going to be a little higher, right? Same thing here. It's going to go up here somewhere, and it's going to be stretching vertically. It's almost like we took each end from the bottom and the top and just pulled it up. Okay? How do we compress it though? Because we see when the number is like greater than 1, we're stretching it. Well, the compression comes in when it's less than 1, but it can't be a negative, so it has to be between 0 to 1. So any sort of fraction or decimal will give us a compression. But that might be leaving you with the question, what does the negative do? And that's a great question. Let's see what the negative does. Right? So a negative a value will be flipping or reflecting the graph along the x-axis. Alright, so we can quickly go in and see that. So let's start with this. Make sure to leave that in the brackets. Okay. So as we can see, we make it 2 or 3, it just stretches our graph up. What if we do -2? Oh, wow. Or just a negative, right? It's simply just flipping it along our x-axis, right? And then if we do a fraction like 0.2, sorry, a decimal like 0.2, we're compressing it vertically, so it's getting wider, okay? And same if we do like 1 over 2 or 1 over 3. So that's our a value. Let's move on to our h value. So what does our h value do? Well, our h value is going to be a horizontal translation. And what does translation mean? It means we're just going to take the whole graph and move it. We're not going to change any of the values, right? So if this is y is equal to x squared, and we want to know what y equals, I don't know, x minus 2 squared, we're just going to take this whole graph and we're going to move it 1 unit right, 2 units right. Now you're asking, but it's negative. Why are we moving it to the right? So this value inside the bracket is always going to be inverse because of the square sign. So it's easy to just memorize it as, okay, inside the bracket, just do the opposite. So if you see -2, you know we're going to go 1, 2 to the right. If you see +2, it means you're going to go 1, 2 to the left, right? So let's see that in real time on Desmos. So let's try x squared minus 2, or sorry, x minus 2 squared. You see that? It moves to the right 2, right? And then if we do +2, we're moving to the left. So that is just a translation. Translation just means move it. Don't adjust the values of the graph, simply move it. Compression, we're actually stretching out the graph or moving it. And then our last value is our k value. Our k value just means vertical translation. And this one works in the traditional way where a positive is gonna bring us up and a negative is gonna bring us down. So let's look at our y is equal to x squared graph one more time. Let's erase the extra letters that came in, right? And let's look at another value like y equals x squared plus 10, or plus 1 for now, okay? What that means, we're just going to move this graph 1 unit up, right? And if it was -1, we would just be moving it 1 unit down, okay? So if we break these down, we can now look at a very complex equation, right? So something like y is equal to -2 times x plus 3 squared plus 4, right? We can now look at an equation like this and be like, oh, okay, I can visualize this, right? So let's start over here with x squared, a graph that looks like this, right? And it'll touch here. Let's make that a little bit neater. Right? So we see the negative, so we know, okay, uh, reflected along our x-axis. Let's do that first, okay? And then we see our a values too, so we know it's gonna stretch a little bit. So instead of just being like a normal like this, it's gonna stretch and be something like this, okay? Then we have plus 3, and remember, inside the brackets, we do the opposite. So now we gotta move it 3 units left. So we grab it, okay. We grab it, and we go 1, 2, 3 units to the left. And then lastly, our k value is plus 4, so we're going to move it 4 units up. So 1, 2, 3, 4, somewhere over here, right? And we can confirm this by taking this that we just drew and throwing it into Desmos. So let's add our -2 out here. Oh, not 22. And then, let's see, plus 3, plus 4. So plus 3 is going to move us to the left like that. And then finally, plus 4 should move us up. Okay? So that's the basic gist of transformations in quadratics. I hope that helped, and I want you guys to play around with Desmos a little bit, and it'll really help you visualize it and see what these transformations do. So every time you see an equation like this, you'll be able to just see it in your head. Good luck!